Sorry about all that. All right, so I am the late render man. So I figure a few people are gonna want to kill me for being late here. Can you hear me in the back? Do I need the mic? All right. All right. I'm Render, as you probably all been cursing me for God knows how long. I write books. I train. Go to a lot of conferences. First time at DerbyCon. Heard a lot about it. Just lucky to have gotten down here, and can't believe I've screwed this up this far. So for this talk, I got to cover my ass. Do not actually try any of this outside of a lab environment. If we're talking about screwing with airplanes in flight, air traffic control, people's lives here. This is like some pretty serious shit. So use this information to make air travel safer, but also use it to, understand how these large systems, can fail in spectacular ways in unintended consequences. I got to fly home from this thing, so I want to make air travel safer for obvious reasons. This is the part of the United States criminal code that covers screwing with any sort of signaling device for air traffic. Basically, don't do it. This is a little bit of a different talk in that I can't really prove any of this because I don't have access to SM-47 in an air traffic control tower in a lab environment. It's all about asking questions, which is what hackers do best. We ask questions. We look at these systems and say, what if? What happens if? So the fourth version of the talk, I'm still asking questions because I still want to get answers. The FAA and all the other agencies basically keep saying, nope, it's classified, and never actually meet me and say, hey, let's get you your answers here. We need to go beyond just the find a vulnerability, develop an exploit, develop a fix, and look at the larger, how did these vulnerabilities end up in the first place? Fix the larger system, not just, the little pieces of it. So I got interested in this purely by accident. Bought an app called Plane Finder AR that you have on your iPhone. You point it at the sky, it looks through the camera, and overlays the flight information for whatever contrail you're looking at. It knows GPS direction, it knows where you're facing, and just does an online lookup and gets this information. And I started looking around, and it's like, oh, there's other sites, planefinder.net, Flight Radar, Radar Virtual, that basically aggregate this data from all over the world, and you get a nice, Google map of all the air travel going on at any particular time. And I'm like, okay, this is kind of cool. Started looking into this, and you've got queries for different types of airlines, different types of planes. You can really mine this stuff. But you start looking into how the app works and where it's getting this information, because it's from a network of ground stations run by volunteers. This is where it started getting creepy for me. It went downhill from there because I was underemployed at the time. I got laid off 3 weeks ago again, so I am now, again, with a lot of time on my hands, and when I get bored, bad things happen. I fly to a lot of these speaking gigs and started thinking about this stuff, and this is why I should always be employed. But before we get really into things, we got to go through, sort of a bit of the history of air traffic control here. Not much has changed since the 70s. The system that is, that it has been is primary radar. You're bouncing a signal off of metal. It's fairly antiquated. It's been around since the Second World War. This provides you your bearing. Not terribly accurate. Doesn't provide accurate altitude. That is supplanted with the transponders that you're always hearing about. The secondary radar that basically queries the plane. Says, hey, ping. The Pong comes back with 4-digit identifier, the actual altitude of the plane, a few other bits of information. Still not hyper accurate, still a vastly manual system. You also, because you've got a spinning dish that can only spin so fast, you're looking at up to 12-second refresh, and a plane going at 500 miles an hour definitely isn't, it changes its position quite a bit in that time. So pilots get no benefit from this. it's all information going to air traffic control. Air traffic control then relays that via voice and other methods to the plane. This low resolution means you have to keep a certain amount of distance between planes because you can't be certain as to where the plane is at any given time. So that limits the amount of throughput that you can have at an airport. You have to have, say 5 miles between planes. That limits the amount that you can put through on a runway. So still a lot of other systems in play nowadays. There has been some other modernization efforts, but it's still a very manual process. Instrument flight rules are essentially waypoint based. It's where you specify, oh, I have to go to this beacon here and then, turn a certain number of degrees here to go there. It's, the long way of doing things. It's not, shortest distance between 2 points. It wastes fuel, limits your traffic because, you've essentially got now lanes in the sky. Your highway can only, handle so much traffic. Other things like weather, there was the Icelandic volcano a couple of years ago that just, completely screwed up air travel because everyone was having to route around that. And this is just, a natural thing. It just causes absolute havoc because suddenly you're cutting off some of those lanes. Something needed to change, needs to make things safer, more efficient. And that overhaul is basically called Next Generation Air Traffic Control. In the late 90s, ICAO, FAA, whole bunch of agencies got together and decided to revamp air traffic control, primarily driven by the states, but what the states does, everyone else kind of has to follow. Do more with the same or less equipment, so they're using very similar transponders, things like that. But they wanted to modernize the air traffic control system over a span of 20 years. So does that mean it's still modern after 20 years? Like the logic there doesn't work. They want to save equipment, or save time, save money, save fuel, increase capacity at airports because a lot of major airports you can't build out anymore because it's now surrounded by suburbs. ADS-B is the key feature of this. This is what this talk is about and the protocol that scares the living daylights out of me. Automatic dependent surveillance broadcast. Planes are now using GPS to determine their position. They broadcast that information over a 1090 megahertz modest link to air traffic control. There's a 978 megahertz version for general aviation, but the effect is effectively the same. That includes the aircraft ID, the altitude, position, bearing, speed. All the information that used to be collected from the ground is now being collected by the plane and sent out. It's received by a network of ground stations. These things are small enough that you can even stick them on offshore oil rigs, so you get coverage in areas that did not normally have radar coverage because you couldn't put a big friggin' huge dish in on an oil platform. Covers those areas, like North Atlantic, Hudson's Bay, Gulf of Mexico. The certainty of the locations allows flights to be packed in a lot closer because if you've got GPS, the accuracy is much greater than just bouncing radar of metal. And this comes in two forms: ADS-B in and out. ADS-B out. This is from the plane to the ground. There's no interrogation needed, so it's just every second, bursting this out. That's the automatic part. Instead of using radar, the planes report the position of their location via GPS. This is the dependent. It's dependent on the plane to report. It's not, an external thing. Omnidirectional, it's just blasted out to anyone that wants to listen. This is the broadcast, and the radar scopes of old are now supplemented with this information for air traffic control. 1090 megahertz for the commercial stuff, 978 megahertz for general aviation. The small little Cessnas and stuff like that. Basically, anything that's flies over 14,000 feet or has 18 seats needs to have ADS-B. The 1090 megahertz one. Everything else below that is general aviation. So, slightly different link format for the general aviation stuff, but it's effectively the same for the purposes of this talk. So ADS-B in, this is now ground to plane and plane to plane. This is optional equipment. This isn't part of the mandatory part of the standard. It can be installed in the aircraft to listen to ADS-B out from other planes. So you now have plane-to-plane communication. This allows planes to be aware of each other, get a nice little traffic map. This is the TISB protocol, Traffic Information System. Allows for real-time weather for general aviation through the FISB protocol, which is Flight Information System. Because your little Cessna typically would have to look at, didn't have access to like flight radar, weather radar like a big commercial airliner would. The situational awareness for pilots grows dramatically. Air traffic control is previously was saying, oh yeah, you got a plane, 5 miles, 30 degrees off your right side. They'd have to look for the lights or anything like that. Now they've got a display, they can see, they know what's in front of them, behind them, above, below. But the problem is this stuff's expensive. $5,000 to $10,000 for ADS-B out, depending on the type of plane. $20,000 for ADS-B in because you've got new screens, new equipment. General aviation market's getting cheaper now. They've basically got receivers that will tie into things like iPads, so you can just use your iPad as the display. Commercial airliners, you generally don't want to have an Apple product installed in the dash. So there's not a lot on the used market, which is a bit of a problem for researchers like me, because I can't spend 20 grand on this stuff to actually play with the real thing. So you have to deal with just reading the public documents and parsing those kind of manually. So in a nutshell, here's the way things work. You've got plane to plane, ADS-B in, ADS-B out, goes to the air traffic control, GPS, fairly obvious system. Now, I'm going to speak about multilateration now. Usually I leave this till later in the talk, but the FAA and everybody, their first reaction when they hear about this talk is, oh, but we use multilateration. What that is, it's almost the inverse of triangulation. It's the time differential between when the signals were received by multiple stations. You use that, you can figure out where, in a two-dimensional plane, where that signal came from. So they're saying, oh yeah, plane says it's here. We're also getting a signal from, right near there. That must be, legit. They say this provides this correlation, but there's no indication that this is used everywhere. And there are no public documents explaining how this is done. It is all classified. Not good. So this was from yesterday. The flights that were over Louisville. As you can see, you've got planes at any given time all over the damn place. So as I was researching all this, the hacker side of my brain took over the more I looked. It's like, oh, this is interesting. I'm getting all this information. I don't have to go through the authorities. Starting to investigate, measures that might be able to mitigate some of the things I was seeing. Couldn't find them. The answer was always, well, just trust us. We know what we're doing. Trust us. Previous experience doesn't usually indicate that that's a good thing. Started digging deeper, found I'm not the only one. And when you actually start looking at this, that looks like a network packet. You've got headers, data, it looks like anything else. But the scary part is anyone can listen on 1090 megahertz or 978 for general aviation and decode the transmissions in real time. It's a simple pulse position modulation. There is no authentication of data from aircraft, just very simple checksums. There's some correlation with primary radar, like I said, and multilateration. I'm running a ground station myself because ADS-B is unencrypted and unauthenticated. Yes, unencrypted, unauthenticated. This is, my desktop at home. I've got a, flight scope essentially on my desktop. I'm reading this stuff because anyone can read this stuff, good or bad, for whatever purpose. You can, other people have been looking into this. Just sort of put them here. Adrian Costin, Hugh Tesso, Nick Foster. All these people have been looking into this stuff, and we've all come to the same conclusion that all these years of research, we cannot find ways that they've mitigated the obvious things that are bad with, having an unencrypted, unauthenticated protocol, running your air traffic. This is being utilized all over the world. 2020, it's going to be mandatory in U.S. airspace. UPS, as part of the testing process, volunteered and paid for equipping their entire fleet. There are ADS-B equipped planes over our heads right now. I fly a lot and want to get home. And And there's a huge amount of threat vectors to look at that are obviously in a lot of your heads right now. So the threat from plane to ground communication is eavesdropping, obvious one. You got capture the clear text, you know what flight is where, you know all this information. You can also, because there is a regular signal, you can use your own multilateration to capture the location of non-cooperative flights. You know, ones like Air Force One that don't actually send out public, or they actually send out an encrypted version, but you know, obviously they're not wanting people to be able to track the exact location of Air Force One, but with multilateration, because you have just a signal, you can work with that. The data mining potential is huge, as you can imagine. You know, we know what flights are in the air, where it is, when it is, where it's going. Could we use this to track some of the extraordinary rendition flights that were going on back in the early aughts? Your attacker has the raw data. There's nothing to stop someone from receiving this. Another obvious threat is what happens if we start now injecting into this system? Inject some ghost flights into this. The documents that discuss fusing ADS-B with primary radar, you know, so that you actually have a verification. Yes, you know, we've got a metal in the air there that is also reporting in the same location. These same documents also talk about discontinuing primary radar because it's expensive. So you won't be having that correlation all the time in all the places. What happens if you introduce slight variations in real flights? You know, start putting data into the system and then just slowly diverging the flights. How does the system deal with, you know, now you've got two sources of signal that are now diverging. How do you know you've actually eliminated the right one? What happens if you cause confusion at inopportune moments? You look at something like the Olympics, you know, where there was massive amounts of flights, VIPs, and everybody coming in. If you introduce just a little bit of chaos into that system for an hour, that ripples across the entire globe. You know, people are already on, you know, high alert in that kind of situation. You know, a bunch of weird shit going on is the last thing they want to deal with. What, you know, could you create regular false flights? Could you have, you know, a smuggler that just said, you know, flies a regular route with a fake flight, you know, to train the air traffic control to ignore it? You know, could that happen? I don't know. The same documentation discussing multilateration, like I said, nothing is denoting its mandatory use. It's all saying, you know, yeah, we have this option, but there's nothing, I can't find anything in standard that says you must use it in all places. Multilateration is that constant excuse in the FAA saying why it's secure. But again, if we've got access to all this raw data, that to me is still just a vulnerability. Multi-point broadcast could defeat multilateration. If I had, you know, 3 stations sitting at different points, I could time my signals going out to their receiving stations and fake locations. Obvious one, jamming. What happens if we jam the ADS-B signals? Well, there's still lots of procedures. I mean, the pilot is still in control. The pilot is, you know, far from a monkey just pushing buttons in the plane. But you now have a much lower resolution in the information coming from air traffic control systems. So you now have to keep planes further separated, keep them, you know, it really would screw up a lot of the advantages. Yes, you could direction find the sources of jamming fairly quickly, but do you have, you know, a bunch of vans on site at an airport on, you know, alert for this sort of thing? You know, can you find this stuff, or is it a case of, oh, you gotta phone, you know, the guys, you know, in the next city over, you'll get the FCC bands out kind of thing. If you targeted the location and timing with this, what could you do? If you jammed, you know, all the planes trying to come into Russia for the Sochi Olympics, what would the effect there be? I don't know. I don't want to find out. What happens if you coordinate jamming across major travel hubs, you know, be it accidentally or intentionally? The example I always like to use is the American Thanksgiving. It's always a complete and utter nutcase of flights, and you know, because you've got like half your population trying to go visit the other half. The effect of jamming, say, New York, Dallas, Atlanta, San Francisco, you do that for an hour and watch the chaos. It would not be fun. Um, this is already kind of happening accidentally because with ADS-B there is no contention protocol, meaning that if you get too many planes, they're just going to start stomping on each other. You can't actually have the density that they wanted because if they're all operating and just broadcasting regularly, they start stomping on each other and garbling the signal. Like, this is not a good idea. Originally, they wanted to have ADS-B transmitters on all the planes on the ground, on all the trucks, the tractors, and everything, all the vehicles, so they could track stuff while it was on the ground. They did that and found very quickly that, nope, it completely breaks. Not a good thing. So that's ADS-B out. That's plane to ground. Now let's look at plane to plane, the ADS-B in. Now injection gets even more interesting because, like I said, multilateration is on the ground stations. Plane to plane, the plane is a single point receiver. You don't have multilateration. You can't verify where that signal came from other than some directionality. What happens if you inject confusing, impossible, scary types of traffic? The sphincter tightening kind of stuff. Holy crap, you've got a plane coming at you. Ah! Where'd it go? System's going to be licked, all these alarms going off and everything. What happens if you introduce data that is different than what air traffic control is relaying? Again, a little bit of confusion. The FAA is always talking about multilateration as their safety and security thing for ADS-B. They've never addressed the plane-to-plane part of it. Now, again, the pilots still have to make, they're in control of their airplane. So they still get to make final decisions. But in a lot of cases, garbage in, garbage out. If I can feed them false data, how are they going to be responding to that? Since the system is now based off of GPS, what happens if you jam GPS? Block the plane's ability to know where it is. North Korea is currently jamming along their border with South Korea. In the UK, they did some tests where they set up a bunch of listening posts around the highways and listened for anything that was broadcasting heavily on GPS frequencies, and they found widespread use along the highways. Newark had a really interesting situation where their GPS receiver on the ground was getting jammed on a regular basis. What it was a guy whose boss had low-jacked his delivery truck, so it was reporting where he was all the time. He would go to the a parking lot right by the end of the runway where their equipment was, where the airport's GPS receiver was, plug in a GPS jammer to get rid of the low jack in his truck, and take a nap. And he would do this like every Monday, every week. So because of that regularity, they were able to actually figure out what was going on, saying, okay, it's Monday, that weird signal is going to come around about 2 o'clock. Let's, figure out. And yeah, it was this guy just unintentionally jamming air traffic. 20 or 30 bucks, Deal Extreme, other sites, you can get these receivers. What happens if you put one in a bag with a timer on it? When you're flying along and suddenly it flips on and, oh, plane doesn't have GPS anymore. This removes all the advantages of ADS-B, causes delays, causes confusion. GPS spoofing, introducing manipulated signals into the system. Aircraft location no longer reliable. Best case, fall back to traditional navigation. Worst case, you're now introducing data into the system and the pilot's going to adjust their course, etc. You can now effectively remote steer a plane off course. Iran, there are rumors that Iran may have used this to acquire a US drone about a year back. Of course, with that situation, you're never going to actually get the truth out of anybody, so who knows what the heck's happened there. But it's already been shown to be done for less than $1,000. Texas did a thing with like a quadcopter drone that was sitting stationary. They introduced a fake GPS signal, and it suddenly thought, oh, I'm not where I'm supposed to be, and it proceeded to then move. This scared the crap out of a lot of people. The threats, there are some threats that are total unknowns. This system is huge. It's hard to parse from public documents. Has anyone got a whole understanding of this thing? Has anyone fuzzed a 747 at 36,000 feet, fuzzed an air traffic control tower? Don't put up your hand because I know you haven't. Have you verified all your chip level code on the equipment? could it be used as a control channel? Drone autopilot integration. So they've now done tests where they've taken, a Predator-sized drone, equipped it with an ADS-B receiver, and as it's flying along on autopilot, introduced another plane, coming at it and saying, "Oh, yep, I'll adjust my course, go around, and return to the automatic, the previous course." But this is a completely automatic system, no human intervention. There's also no multilateration. So if I start saying, "Oh, there's a plane on your left," it'll steer right. Say it's on your right, etc. I can now remote steer a Predator-sized drone. Yeah, that's like the biggest RC plane I would ever want to play with. But what happens when a Predator-sized drone decides to just suddenly drop in on a suburb at low altitude? Sphincter is going to tighten all over the damn place. The sequestration, if that's even a word, that occurred down here threatened 173 tower closures. They said, "Oh, we've got this automated system. We'll cut out the middlemen, in the flyover states that handle a lot of this stuff." That means more work for air traffic control, and it's already one of the most stressful jobs out there. Congress restored funding because this might actually have caused them delays in getting the flights, so they put that money back. But it's still the fact that they thought that this was in some way a good idea just shows nope. You would hope that the engineers, the FAA, DHS, everyone else looked at these threats, but not to my satisfaction. The FAA says, "Oh yeah, we submitted ADS-B to NIST for security certification," but the FAA specifically assessed the vulnerability risk of ADS-B broadcast messages being used to target air carrier aircraft. This assessment contains sensitive security information as controlled under 49 CFR Parts 1 and 1520, and its content is otherwise protected from public disclosure. And that gets worse. While the agency cannot comment on the data in this study, it can confirm for the purposes of responding to the comments in this rulemaking proceeding that using ADS-B data does not subject an aircraft to any increased risk compared with the risk that is experienced today. And of course, the risks that are experienced today are also classified. So it could be, everything's about to be on fire, and say, "Yep, it's, using this new system, they're still going to be on fire." They won't tell us what those threats are. They're comparing to an older system. What about threats that ADS-B, weren't possible with the old system? What about stuff we haven't thought of yet? This sounds a lot like security by obscurity. And NIST is the same people that came up with the system security should not depend on the secrecy of the implementation of its components. This is the NIST Guide to General Service Security. What's good for the goose should be good for the gander, but nope, in this particular case, they're saying we're going to keep things obscure because that's more secure. Obviously, there are some threat mitigations that could be done. Multilateration, obvious, make that mandatory everywhere. What about if the data doesn't match, though? How are you representing this on air traffic control scopes? How are you filtering this? Liability issues. If the manufacturers basically say, "Oh, we're not going to trust that data," and don't put it on the scope, how are they dealing with that? What are the liability issues if they get it wrong? There's a great many unknowns. FAA has said they've never detected a ghost flight. Well, maybe no one's actually tested this yet. Just because you haven't detected something doesn't mean it's not happening. The response is always trust us. The last time I ran across this excuse was looking into RFID-based passports, and we all know about the wonderful security in those. I don't know about you, but anyone that says trust me, I don't. I'm not trying to spew FUD. I'm trying to get awareness and pressure on these agencies to come up with the answers to these things. To make meet us halfway and say, "Hey, we've got a vested interest in this because our butts are the ones in the seats." I want to see what their procedures are for when weird crap happens. I'm way behind then. Hackers looking at air traffic control will and has gotten response from them. We got to keep up the pressure. I'm not going anywhere on this. The Office of the Inspector General is conducting an audit on this. The President specifically mentioned air traffic control as something that he wants to focus on as part of the cybersecurity strategies. But the response is always going to be, "Oh, it's too expensive for the common man. I can use a $20 USB TV tuner to receive these signals." So I don't need expensive equipment to do basic receiving. Mike Osman's HackRF has my attention as a cheap receiver and transmitter for fairly low cost. We're talking like $300. I got word while in the air to a conference in Poland that Nick Foster had implemented ADSB out in GNU Radio. We have the ability now to generate arbitrary ADSB packets and put them into the air. Where's the GNU Radio plot? He also raised his game to badass. He basically implemented ADSB in on Flight Gear, an open source flight simulator. So it populates the flight or the simulated environment with with real world planes. So your virtual environment is reflecting the real environment. The output also pseudo matches the real plane's behavior. So he also implemented ADSB out from your virtual plane. So your little Cessna or whatever plane you've got configured is now generating data as a real plane and putting it out into the air. So because it's follows the real plane physics, the course and everything, it's going to look the exact same. Oh, and Flight Gear also has scripts that allow you to do an intercept course. So got a little video here. Essentially, you're going to see on the left, this is the virtual plane. The right is a Google map from a ADSB in receiver, and the data stream is on the bottom there. So you can see, if you look on the Google Earth there, just taking off from SFO is Flight Your Mom. That's our virtual plane there taking off. You can see it's flying along over the San Francisco Bay. ICAO registration and everything. And on the right you can see that there's other real flights that are also populated in this. You can see the light blue line, you can see where he took off from SFO. He's now looping around the bay. And apparently when he was recording this, he says, his flying was really bad because on his left he's got the flight control stick. He's trying to pilot the plane. On the right, he's manipulating Google Earth, all while laughing maniacally because he's about to buzz the tower. So you can imagine being an air traffic controller and seeing this weird flight pop up that just turned around and is now aiming itself right at the airport. That's not a good situation. And if you've only got a few seconds to make some decisions as to what's going on, like, your day is gonna suck. And I love the fact that he buzzes the tower inverted. So this proves, I mean, all of this testing was done. So as you see, we have the ability to do this. This testing was done on some modified equipment, so it was in the 900 megahertz range. It wasn't actually broadcasting over the air. It was just through a coax cable from the transmitter to the receiver. So it was all safe, but the system exists. We could theoretically just dial this up to 1090, stick a amplifier on it and an antenna, and start broadcasting into the air. The next guys might not be so nice. There's other threats. Tailored arrival, air traffic control uploading a landing plan unencrypted to the plane. Has anybody started poking at that? Aircraft are huge, complex systems. Air traffic control is larger. I would wager that it is probably one of the biggest networks out there. It is so many interconnections, so much communication going on, it's ridiculous. Reading up on one system allows you to leads you to other things and how they interact. It's a humongously tightly integrated system. So the future is ADSB will be mandatory in the US by 2020. Already in use. Can I just go long? Like, is there somebody else in this room after? There is? Ah, crap. Basically, if you have a 747 or air traffic control tower available, I'd like to do some testing. I'm going to skip the TCAS thing and just go right to the end. I can do that. I can show you that out in the hall or something, but basically ask questions. I want to prove myself wrong here. I want to be wrong. Help me with this. If I can make all of my documents available to you, read on this, learn on this, keep pressure on those guys. I want to find out that this stuff is safe. If not, I want to help make it safe. So thank you. I apologize for being late. I suck.